Okay, this is conic sections review worksheet. First problem. So because of the plus sign, because these numbers are different, this is an ellipse. Okay, so the first thing we're going to do is find the center. So the opposite of the number with x is -2. The opposite of the number with y is 4. I'm going to go and plot that at the same time. And there's your center of your ellipse. The vertices, there are 4. So the 25 is going to be your a squared. It's bigger than 4. So that's a, and that's plus or minus 5, and it's underneath x. So we're going to move 5 to the right, which that is 3, -2. I'm sorry, 3, 4. 3, 4. And we're going to move 5 to the left, 2, 3, 4, 5, which is -7, 4. Notice they share the same 4 as that one. Now the co-vertices, it's going to be b squared is equal to 4, so b is equal to plus or minus 2. And we're going to go up 2 and down 2. So I'm going to draw this, and then I'm going to label them. So that's what your ellipse looks like. So this point right here is a little bit off. This point right here is -2, 2. And the other one is -2, 6. Those are your co-vertices. Your foci are found by using this formula right here. And a squared is 25, and b squared is 4, and that is 21. So c is plus or minus square root of 21. What is that? Square root of 21. About 4.6. So you're going to go 4.6 to the left, and 4.6 to the right. And that's how you plot them, but to actually say it, these foci share the same y-coordinate as the center and your major vertices, which is 4. So the 4 is going to be unchanged. So you're going to take the x-coordinate of your center, and you're going to add and subtract square root of 21, and that's the best way to write your two foci. That's actually representing both of them. And that's your answer. And the next one, I'm going to write this, and I'm going to actually subtract the y so that it's all equal to 0. This is a parabola because we only have one squared term. So to find the vertex, we are going to complete the square. So what we're going to do is going to keep the x's on one side, and we're going to add y and subtract 4 to the other side. Because you cannot complete the square if there is a number larger than 1 in front of the x squared, we're going to factor out a 2. Now that there's a 1 coefficient here, we can go ahead and complete the square. So half of -4 is -2, and -2 squared is 4. But what are we adding to the other side? We're not adding the 4. We're actually going to add 2 times 4, which is 8 to the other side. So on the left side, if you factor, you get x minus 2 squared, because half of -4 is -2, or the square root of 4 is 2. You can do it either way. And -4 plus 8 is 4. Now this is just about done. In standard form, we need to get rid of the 2. So if you divide both sides by 2, you would get, I'm just going to write it as 1/2 y plus 4. Dividing both sides by 2, it's going to be a 1/2 on the other side. So this is your standard form. This tells you a lot. It tells you what your vertex is, first of all. So the opposite of the number with x is 2. And the opposite number with y is -4, which is right there. And then we're going to set 4p or 4d, doesn't matter, 4d, 4p, equal to 1/2, that coefficient out front of the y term. And then if you divide by 4, you get p equals 1/8. So to get the focus, we're going to go, since this opens up because x is squared and this is positive, we're going to go 1/8 up. So that's kind of hard to say what that is as a word pair, but it is going to be 2 and -3 and 7/8. Now the directrix goes 1/8 the other way, but it's a line. So it is y equals negative 4 and 1/8, which is negative 33/8. If you want to get exact points, you can punch in the 2x squared from the beginning. Sorry about the announcements. 2x squared minus 8x plus 4.
Good morning, Panthers. It's Monday, March 5th, and I'm Cassie.
And I'm Carly. The Panther Cafe is offering double burger, onion rings, carrot sticks with dip, romaine salad, and a fruit cup for lunch today.
What's up, North? I'm Rachel, and now a public service announcement.
So here's the graph. So if you go to T-table, just find some points located around 2. So I like to see 0, 4. I like that one. And 4, 4. I also see like 1, negative 2. And 3, negative 2. You might as well get some points like that to make it look nice. Because the latus rectum is so small. The latus rectum is only 1/2. So between the focus, it's just like right here and here. Those points are so small and hard to graph. So that's it. This conic section is a hyperbola because of the minus. The center is way down here. I'm going to do that next. The center is 2, 1. That's your, can't see that. Get the graph. So there's
Attention
2
all
ones right here.
juniors who received
That's the
a letter
center.
regarding joining the National Honor Society.
So
the meeting that was originally
notice that
scheduled
this
for
is
Thursday,
the
March
positive
1st,
term.
has been
So
rescheduled
that's your a
for
squared is
Wednesday,
9.
March 7th at
So
3
a is
p.m.
plus
in
or
the
minus
lecture
3, and because
hall.
it's
Please
under
see
x,
Mr.
it's going
Eilish
right
in
and
room
left.
237
So
if you
this
have
is
any
our
questions.
vertices, and this is the
And
way.
now
This is
today's
where the
Panther
hyperbola will
Sports
open
Report
from.
with Joel and Abrar.
What's good, all you Panther
So
sports fans
negative
out
1,
there?
1.
It's not Chloe, but Abrar and Joel here with your Panther Sports Report.
And this
Thanks,
is
Abrar. Any boys interested in playing volleyball, be in the gym today by 3:15 p.m. for practice.
Any girls interested in track
5-1.
and field? The season officially starts today.
And now, back over to Rachel at the anchor desk.
Okay,
with
now
the
I'm
late
going to do a
announcements of today's
box.
birthdays.
Okay, the box.
Happy birthday to the following
Set your
Panthers. Alexis Van
negative
Cannell,
term,
Angela
16 equal to
Verdone,
b
and a
squared.
special happy
And
birthday
b is
shout
plus
out
or
to
minus
Brevard,
4. Now this
Brianna,
is
and
just to
Gianna
make a
Castillo.
box.
That's all for
It's
today's
going to go
show.
4, but I'm
We hope
putting
you
an
have a
X here
great
because
day.
that's not
This
your
has been
vertice.
Cassie
Carly.
and Rachel reporting for the North News
Put an X here
Network.
because you don't have to tell me what it is, but it's just there for the box. And then to make the box, make sure all these vertices are the midpoints of these line segments, length and width. So make sure you're very careful here. Here's your asymptotes. And your hyperbola is going to open from the vertice 5, 1. Make sure you get really close to those asymptotes. And from the other vertice, negative 1, 1, we're going to open the left curve up. So the equation of those asymptotes is y minus k equals plus or minus b over a x minus h. So the y and the k is the center. That's the 2, 1. So it's y minus 1 equals x minus 2. That's that part. The b and the a, it's going to be plus or minus 4 over 3. You can get that from the equation, or you can just look at this box. It went from the center, that's a point on the line. You go up 4 over 3. That's your slope, 4/3. And the other one's a negative 4/3. So that's fine if you want to write your asymptotes like this. But what they really are, if you separate them, like the first one would be y minus 1 equals 4/3 x minus 8/3. And if you add 1 to the other side, adding 1's like adding 3/3, so that'd be negative 5/3. This is actually your line, your first asymptote. Y equals 4/3 x minus 5/3. Let's see if our asymptote's on point here. So negative 5/3 are like negative 1 and 2/3. So where's that origin at? Right here? Negative 1 and 2/3. Look at that. It's pretty darn good. It's pretty close right there. And if you go up 4/3 from here, 1, 2, 3, 4 over 3, you're right on the line. So this is an accurate line, but we did it with the box, which is the same thing. This is just actually writing the equation. And the other one would be y minus 1 equals negative 4/3 times x minus 2. So if you distribute that, you get negative 4/3 x plus 8/3. And if you add a 1 to the other side, you get, add 3/3, that'd be 11/3, which is like 3 1/3. So our second line, if you find the origin, is 3 1/3. Look, right there, that's 3 1/3. And then you'd go down 4 over 3, and you'd be right on the line. So these are your actual asymptotes. I'm okay if you write it like this. And your last thing is your foci. C squared equals A squared plus B squared is the formula. So C squared equals 9 plus 16. C squared is 25, and C is plus or minus 5. So your foci, from your center, count 5. 1, 2, 3, 4, 5. That's foci 1. And then from your center, count 5 the other way. 3, 4, 5. That's foci 2. Make sure you know they're inside the curves. And to list these, because these are not radicals, I want the actual foci points this time. You can actually look at the graph to tell me what these are. This is -3, 1. And the other one looks to be like 7, 1. So your foci should be listed if there's no radical. Find the equation of a circle that is tangent to the line x equals 8. -5, 10 is right here. This is the center. It says it's going to be tangent to the line x equals 8, which is this line right here. That means the circle's got to touch it there. So your circle's going to be like something like this, right? It's got to be tangent to this line while x equals 8. That means it just touches it. So what is the radius? This was -5, correct? And if you have to go over to 8, that's 5, and 8 more is 13. That's a distance of 13. That's your radius. So if you know your center and you know your radius, you can write the equation of a circle. That's your equation of your circle. And that's page 1.